everybody. Excuse me. Welcome to today's webinar. We're going to be talking about monitoring Tempdb database and trying to understand, what's causing issues in Tempdb, alerting on Tempdb, reporting on Tempdb, etc. I'm the only person on the call from IDERA today, so I don't have any feedback as to whether or not you guys can see my screen and or hear me. I'm assuming you can. There is a question and answer section within GoToWebinar that you guys can type in that can help me understand that you can hear and see. Oh, perfect. Thank you. I appreciate it. All right, so let's go ahead and get started. The goal of this call today is to kind of highlight some of the feature sets built into SQL Diagnostic Manager that is directed towards Tempdb, right? Tempdb issues can cause a lot of problems. It can crash servers. It can slow things down significantly. There's a lot of issues that Tempdb can cause that are catastrophic, right? And one of the things that SQL Diagnostic Manager does that's really important is that it has a lot of historical data available for you. So if something does go wrong in the past, there's different ways that you can look at that SQL Server instance historically to understand the root cause of that issue. And Tempdb is included in that historical view, right? For people who may not understand or have used SQL Diagnostic Manager in the past, it's probably a good idea to do a quick kind of overview of what it's doing and how it works. The general idea is that this is designed to be comprehensive SQL Server monitoring. So it's not just looking at, logs. It's not looking at high-level SQL Server data. It's trying to look at SQL Server holistically across the operating system and the SQL Server, including virtualization data if you are virtualizing. So it's looking into a lot of different aspects of the SQL Server using instrumentation like SMO, DMO, sysperfinfo, DMVs, dynamic management views, extended events, query store data, right? So it's looking at lots of different areas within SQL Server, basically at a timed interval. It's reaching out through what we call the SQL DM collection service every minute, 5 minutes, 30 minutes, however frequently you ask it to. It collects a bunch of historical data, collects a bunch of live data, then stores it in a database and then gives you access to it historically. It's also pulling data from the operating system through WMI, and then if you're virtualizing either through Hyper-V or VMware, it's pulling data from vCenter, for example, to help us understand how the host is behaving in contrast to the virtual machine. So once all this information has been gathered, it gets stored in a database, which is a SQL Server database. And in that database, then we have the ability to do things like reporting, right? So we can do capacity planning, training, and analysis reporting. We have that DVR functionality that we have built in the tool called History Browser that lets you rewind the clock and go back in time. And then we can also use history to better define alert thresholds. So because we know how a metric has behaved on a SQL Server, we can compare that to your current alert configuration, what is warning, what is critical, and then give you some guidance on where you might want to make some adjustments. So that history is pretty important. Once alerts have been identified, right, something has breached a warning or critical threshold, there's a lot of different things we can do with that information. Obviously, there's notification, right? You can send out email, you can write to the event log, you can send out SMP traps. We have direct integration with SCOM, so if you're a SCOM shop, we can send that information directly in there. But you can also take actions, and some of those actions may be more notification type action. I can use a PowerShell script, for example, to integrate in with some other monitoring system. I can use a command line script. I can run a T-SQL command. I can run SQL agent jobs. So those actions are mostly used for remediation, right? I'll give you some examples when we get into the demo, but when XYZ happens, run this T-SQL command to fix XYZ problem, right? So there's different ways that those alerts are of value to you. They give you some guidance within the tool where you need to go to find, which servers are having problems, what types of problems are they having, but they can also notify, etc. And then lastly, I think the most important takeaway from an architecture standpoint is that it's agentless. We don't install anything on the SQL servers that are being monitored, and that gives us a lot of flexibility on what can be monitored. So we have support for cloud environments, not just your infrastructure as a service like EC2 or VMs within Azure, but you have the ability, from an AWS standpoint to monitor both EC2 and RDS. In Azure, we support, managed instance, database, and infrastructure as a service. On-prem, basically any SQL Server, both Windows hosted and Linux hosted. And then we, again, have support for Hyper-V and VMware. So everything that, from, I think, basically SQL 2000 up to 2019 can be monitored. Standard, developer, enterprise, express, all can be monitored with this product. So just about everything can be. And part of the reason why we can do that is it's agentless, right? So when you do, if you haven't already, if you decide you want to download a trial, or if you're an existing customer, then you'll probably be familiar with this. But if you're downloading a trial, basically wherever you install or run the installer for the product is where the services piece or the application part of the tool will reside. So the services are doing the data gathering and the alerting for you, really. The primary services are SQL DM collection service. Again, it's the piece that's reaching out over the, the WAN or the LAN and collecting all your SQL Server and OS and virtualization data. So it's going out at a timed interval, collecting a bunch of stuff. It brings that data back to our management service. SQL DM management service will parse through that information. It's looking to make determinations around alerting, right? So, is the CPU high? Did the job fail? Do you have a block or a deadlock? Something like that, right? And then it's storing that information for us in the repository. So the back-end repository could be on the same server as those services, but once you start monitoring more than 100 or so instances at a time, we would probably recommend that you have a separate server hosting the database and then another machine hosting the services. But if you're, a smaller shop, you're not monitoring hundreds of boxes, you're, monitoring 10, 20, 30 SQL servers, you're probably just fine putting everything on one machine. So you have some flexibility there. It's really up to you on how you want to architect that. But basically, the end result would be you have a services machine that's doing all the data collection and alerting for you. You have a database repository that's storing all the history. That repository is going to grow right around 2 to 3 gigs per instance per year. So you're monitoring 10 instances, let's say, plan for 20 to 30 gigs worth of data after 1 year's worth of data collection. Now, we don't keep the data forever. There's some grooming that's done to a SQL agent job nightly, but that's pretty configurable on data retention. Out of the box, it's configured for really detailed stuff for 31 days. And what I mean by that would be like weight statistics, individual sessions, poor performing queries, deadlocks, blocks, our history browser data. That stuff is 31 days. You have really detailed information you can work with for a month. After that, we start kind of deleting, that 31st day's worth of data will get deleted every night. So you have 31 days of rolling detailed information, higher level stuff like, resource utilization, transactions per second, that kind of stuff we keep for a year. And then growth rates, disk, database, and table growth rates are kept for 3 years. Again, this is all adjustable, so you can keep more or less data, but if you leave the defaults in place, which is detail for a month, everything else kind of a year, growth rates for 3 years, look at 2 to 3 gigs per instance per year. What we haven't talked about yet, though, is as an end user, how do I get in here and work with the tool? And really that's related to the console. So there are, sorry, I'm checking the questions real fast. There is, if you're coming in a little bit late, there is a question and answer section within GoToWebinar. Please feel free to write in questions if you have them. I'm happy to take those. So as an end user, the desktop client is probably where you're going to spend most of your time. There are web consoles also available for SQL Diagnostic Manager, but the web consoles aren't as feature rich. They don't have any administrative facilities like adding servers and changing alert thresholds and things like that. So think about it this way. If your job is really managing SQL Server or dealing with SQL Server on a regular basis, you'll want a desktop client. So the SQL DM desktop client is a .NET application. It lives on your workstations, right? So your laptops, your desktops, really anybody in your organization that you want to have access to SQL in detail can install that desktop client. Now, there are controls around it, so you can say who can and cannot have access. Not only that, but you can limit what they have access to. So some users may, like myself, I'm an administrator. Actually, let me do this. Let me switch over and kind of show you what I mean here. So this is my desktop client. Okay, so we're monitoring 11 SQL servers right now. We're looking at one of them individually. You can see that there's an alert currently on Tempdb. Interesting. And what I was getting at was under administration, there's a section of the tool called application security where I can control who has access to this product. So yes, anybody can install it on their laptop, but that doesn't necessarily mean they're going to be able to use it, right? You're controlling who has the ability to connect in and start working with the tool. Not only do they have access, but what type of access they're going to have. So for example, David's listed here as administrator, right? So I have complete control of the product. I can add users, add servers, remove servers, do anything I need to. Deanna, though, on the other hand, who's one of our lead SharePoint developers, we've enabled her through her individual AD account. Now that could be a group as well, but we're looking at individual user right now. She's enabled, and she's limited to a view-only role, right? So her permission only allows her to view SQL Server and their information. She can't add new ones. She can't change configuration thresholds or anything like that. She can just view the data. And I'm even limiting her on that. I'm monitoring 11 SQL servers. She can only see 2 of them. And I'm doing that through what we call a tag. You can think of a tag as almost a group, right? So it's a logical organization unit related to a SQL Server instance. And each instance could have multiple tags associated to it. So it's logical and non-exclusive. Nevertheless, because I've given her access to the SharePoint tag, if I come in here and say, well, let's also give her access to the dev tag, she has more servers, right? But the really cool thing about using tags as opposed to individually selecting the one she should have access to is I can change that tag, right? So after the fact, if I add another server to it, she's going to have access to that new one instead of me having to go in here and edit her individually or multiple people individually as to what they have access to. So there's a lot of control that you have over who can get in here and start viewing servers. The next step in the process, obviously, once you get it up and running, is adding servers. And the wizard will, once you install it, will walk you through that. The first time you open up the console, say, hey, there's no servers registered. Do you want to register some? And basically, that looks like this. It'll be blank. You'll say add, and then it'll walk you through a wizard. It's really simple. What servers do you want to monitor? It's going to look for servers. Mine are already added. Let's just put in a fake one, SQL 1, and maybe I want to add 2 of them, SQL 2, semicolon, SQL 3, right? So you just semicolon separate them, add them. What type are they? Well, these are all Windows boxes. They're not even real, but nevertheless, you tell us, is it Windows, Linux, Azure, RDS, that kind of stuff. And then the polling interval, the default 6 minutes, which is okay. I think for servers that you really want a lot of resolution on, I'll probably drop that a little bit lower. But if I'm adding 300 servers at once, I may go ahead and add them at the default, which is 6 minutes. Query Monitor I'll talk about a little bit later on, but I generally, if I'm a brand new user, am not going to just immediately enable that because I want a baseline of monitoring. What does the monitoring look like from a performance standpoint before I enable any kind of detailed monitoring like query monitoring, just so I can see how query monitoring may affect overall performance of that SQL Server. But if you're comfortable with it already, go ahead and turn that on. And then lastly, setting up WMI. So when I'm connecting up to the SQL Server, how is it that I'm going to collect WMI data? Do you use the collection service account, or do you want to use some other account to do that? So the SQL Server adding part is pretty easy. You can tag them when you're doing that, so you can start organizing them into groups. You can define out-of-the-box alert thresholds using templates, which there are quite a few, but you can create your own on the fly if you wanted to, and then hit finish, and you're done. So adding those servers is pretty simple, and that was adding 3 servers. Adding 300 is not very much more complicated. You just hit next. So once they're in here, you can come in and tweak them a little bit more after the fact. So I was mentioning something about query monitoring. So this server, my polling interval is 1 minute, right? So I'm gathering data more frequently. If you look behind me, these charts here are 1 minute charts because that's my polling interval. So I have a snapshot being taken of the actual performance of the server every minute. I do test more frequently, every 30 seconds, to see if the server is available, and then I'm collecting database metrics. So how full are the log files, log files, data files, file groups, database growth rates, and things like that are happening at 5-minute intervals. So one takeaway here is 1 minute is a long time, right? Especially in the SQL Server world. So there are certain things that I want to do between the polling intervals to help backfill data, and query monitoring is one of them. Now, the reason why I might not just immediately enable query monitoring is I want to know how enabling query monitor would affect the SQL Server's performance, right? So if I don't turn it on for a day or two and just monitor without it being enabled, I know a little bit about what is normal, and then when I enable query monitor, I can show you, where the deviation is there. The reality is, depending on the version of SQL Server, there's very different ways that you can do this. Assuming that you're running 2008 or above, you can use extended events. If you're below 2008, so 2000, 2005, before X events were available, you'd have to use server-side trace, which is not terribly performance causing, but what it is lacking is execution plans. So the trace option will not have execution plans. That is a big drawback. So good news is most people are on 2008 or newer, and that's where you'll go with your extended event option. So we'll reach out to that remote SQL server, create an extended event collector. That extended event collector will then gather, and let me make this a little bit bigger, gather poor performing SQL statements. And that's the goal here. It's not to capture every SQL statement, it's to capture the poor performers, the ones you want to know about that are causing issues. My definition for that was 1 second. So that extended event collector would be looking at any queries, batches, statements, or procedures, triggers over 1 second duration. And then every minute, because that's my polling interval, we'll bring that data back over. Now, luckily for me, I think luckily, I'm running newer versions of SQL. So 16 and above, 16, 17, 19, you can use Query Store in lieu of or instead of extended events. So what that's really all about is piggybacking off the already existing Query Store data. So if you haven't enabled Query Store on the newer versions of SQL, and you want to use the Query Store option in Diagnostic Manager, you would have to enable that manually on the remote SQL server. We do not enable Query Store, so that is something to keep in mind. And if you think about it, this is an instance level configuration. Query Store is a database level configuration. So if you enable it on some databases, but not all databases on, in this example, instance prod 1, you would only see queries on those databases that you had Query Store enabled on. I do prefer Query Store. I think it's very efficient. It's also a little bit more flexible. If I change my mind, 1 second is too long. I want to see everything over 500 milliseconds. Well, the next polling interval, it's going to reach out to Query Store and say, hey, anything over 500, well, because that data is already there, it's going to pull even more data in, right? So it's a better option, in my opinion. If you're using it, definitely go with the Query Store option. The other little tweak as far as configuration goes that I think people will probably want to do is indefinite wait monitoring, or 24/7 wait monitoring. What we mean by that is detailed query wait monitoring is looking at wait type by session, by user, by application, by host, by database, by statement. And that's a lot of information for me to keep in my repository. Therefore, you'll see more growth. Instead of 2 gigs per instance per year, you're going to be a lot closer to that 3 gigs per instance per year. Although we only keep it for 30 days, it's still going to cause that repository to grow. But I think it's beneficial, and you'll see in this demo in a little bit what I mean by that. So on these servers where you have a lot of detailed interest or interest in detailed workload, certainly set this to indefinite. I also am not a big fan of extended events or Query Store for wait data. DMVs are really good at wait data. They're already there. Let's just use those. So I generally would recommend, if they're checked, uncheck the ones that the boxes at the bottom, just go with the DMVs. The last little tweak that you may want to do is activity monitoring tweaks. So, this is looking at things like auto growth, deadlocking, and blocking. And auto growth may be, from a Tempdb perspective, if Tempdb is auto growing, maybe that's something I really want to know about. So certainly something I want to capture. But you may tweak what your blocking threshold is. The default, which this is a Microsoft setting, so the Microsoft SQL Server default blocking threshold is 30 seconds. If I change it either in SQL or if I change it in Diagnostic Manager, vice versa, it's going to change in both locations. Nevertheless, I've lowered this to 5 seconds. So any blocks over 5 seconds, I definitely know about and I have a report on. So those are some of the general kind of ideas. How do I kind of tweak this to get the monitoring, set up exactly how I like? Now, one other little side note around this, which I'm not going to show you, but just kind of describe, PowerShell commandlets for Diagnostic Manager are pretty comprehensive. So adding servers dynamically through PowerShell, tweaking all those little configurations we just talked about, all that can be done through PowerShell. So if you're going to add, 500 SQL servers, you may script that through a PowerShell script. Probably more realistically, what people are doing with that PowerShell is, I'm doing a weekly deployment of a new SQL server. It seems like, well, in my scripting that I use to deploy that SQL server, I throw in the PowerShell for Diagnostic Manager at the same time. So as soon as that new SQL server is built and deployed, it's automatically registered to Diagnostic Manager. But there are some cool things you can do with PowerShell. So that's how the data is getting in here, right? So we're getting 1-minute charts in the background because we're doing minute polling interval. If I drop over and look at something like weight statistics, I have this whole big long trail of weight statistics broken down into a timeline where I can see the statements and the applications, right? So this is that query weight monitoring we were talking about earlier. Interestingly, there was some blocking. It looks, I say blocking because I'm looking at the weight type here, intent shared. There's some blocking. It looks like, I think, right around, 10 o'clock, about 20 minutes ago. So when I talked earlier about that blocking threshold process, you can see here, so it was blocking. We can see that it happened at like 10 to 10:05. Here is a report on that, right? So lead blocker, what's being blocked down below. Pretty simple stuff. But again, the general idea is that's what this tool is trying to do. It's trying to make it easy for you to understand historical issues within SQL Server. And one of the things about this SQL Server right now is it's pretty happy. We have a little Tempdb alert here. Version store generation ratio is critical, and guess what? It's no longer critical. It's gone away. All right, so this is a pretty straightforward view of this SQL Server. Nothing going on. If I go look at active alerts, it's empty. So right now we're pretty happy. That being said, I know earlier in the day we did run into some issues where a session was chewing up a lot of Tempdb space. If I go over to databases and I look up here, so up here at the top is a ribbon of different areas to go look at. So this is just a generic view of databases where I can kind of highlight and start charting out things like, how full are the data files, how big are they, that kind of stuff. More importantly, though, we can kind of look. Here's Tempdb, right? It's about a 4 gig setup, right? So in my case, that's 4 1 gig data files. We'll look at it more directly. So if I go look at Tempdb summary, 4 1 gig data files, right now they're basically empty. We can see the space being utilized total across the board is around 16 megs. Not much going on here. Now we're only looking at 1 hour. Here are the spids down below. Now there's Tempdb contention charting over here. There's also going to be version store generation. That was that alert we saw earlier. So that kicked up to 24 kilobytes per second, or 2400, kilobytes per second about a minute ago. So there are some different charts that you can view. But right now, I'll just say that I'm quite happy with what Tempdb is doing. There's actually nothing very much at all that Tempdb is doing, but that's not always the case, right? Time is pretty important in this tool. If you look up here at the top, it says real-time Wednesday, January 26th. If I wanted to go back, let's say 8 hours or 6 hours, I just changed, and it's kind of hard to tell because this is pretty flat, but I just changed this from a 1 hour chart, so 1 minute over 1 hour. Now I'm looking at 1 minute over 6 hours. And we can see right in here, Tempdb jumped to almost 4 gigs, 3 gigs of data right around 7 o'clock this morning. So that's something I'm pretty concerned about because my total, 4 gigs is the total of disk space I have available and file space that I have available. So that's something I might want to research and do a little bit more around. So visually, it's easy to see that in the chart. There's a couple of different ways you can go back in time, but I want to show this to you a couple of different ways. So let's go back to 1 hour. So the last hour, again, we didn't have that specific issue. So the way I knew that that was there was I got an alert earlier in the day. And that alert that I saw was an alert called Session Tempdb Space Usage, right? I went too far. This one right here. Okay, so if I hit apply, we don't have that issue right now. So there's no active Tempdb space usage alerting going on in the system at this minute. So let's go back over a couple of days and see when the last time it happened. So when I hit apply here, from the last 3 days, we have 45 different alerts related to this metric. Now, earlier we saw that chart around 7 o'clock this morning. We saw that growth in Tempdb, and it actually, at 7:20, right, 7:20, it was 1.5 gigs. And then a minute later, at 7:22, it jumped up to 3 gigs. So we can see a lot in this alert. If you look at the bottom, you can kind of visualize this as an email. This is basically what the email would have looked like that I got. It said a session, so session 70 on DB test is using 2.9 gigs of Tempdb, right? It's using 2.9 gigs of Tempdb. It's coming from this machine. It's this database, this application, which happens to be a job in my case, this user, this host, this bid, and even the command. So this is an execution of a stored procedure called Tempdb workout. Right, so Tempdb workout is doing its thing, causing a bunch of Tempdb growth right around 7:22 this morning. And then at 7:23, it's gone, right? It's lowered back down to okay. So this is something that, luckily it didn't get out of control to the point that it crashed the disk. It stopped itself eventually. So what did this look like, kind of holistically across the system? If I right-click on an alert that happened in the past, I could say show real-time, which takes me right back to that view of what we just saw, a live view of Tempdb. That's not really what I'm interested in. So we're not going to do that. We're going to right-click. In this case, we're going to say show historical view, which took me, instead of looking at that 6-hour chart, we're still looking at 1 hour, but it changed the time context to 7:22 this morning. So this actually happened 2 times in a row, right? So at 7:10, I guess 7:17 went away, then 7:20, 7:23 it ended. And if I walk forward in time by using these arrows up here, you can see it ended, right? So if I go back to the point there where it was at 3 gigs, that was SPID 70. So we have a pretty good idea, right? 70, we see the growth. It's certainly very unusual. We're getting to the max of the file space. Let's check version store. So there's a little bit of version store going on here, nothing unusual, right? So this is really just growth in Tempdb. So let's look at the sessions, right? So if I say view session details, here's 70 right here at the top. Here's every other SPID that was running at that time. So again, we already kind of know this stuff. So Tempdb workout, where it's coming from. But what I didn't really know is how was this affecting CPU and I/O compared to everything else on the system. And in this particular case, 70 is the heaviest CPU consumer by far. It's also the heaviest I/O consumer by far. So if I was getting notifications around CPU, as an example, so you'll see, CPU is pretty flat, pretty normal, and then all of a sudden it got really busy, 1 spike, down 2 spikes. If I go look at something like disk, all of a sudden that T drive got super busy. I guess you guys can assume what's on the T drive, my Tempdb files, right? So the Tempdb files, DB test is down here, but Tempdb files got really busy. So maybe that's what I noticed. I got a CPU alert, I got a disk alert. Well, if all I got was that disk alert, or all I really was working off of was the disk alert, if I come in and look at the SPIDs and sort by CPU or physical I/O delta, well, this is the SPID that's consuming the most I/O. Same thing, CPU delta. This is the SPID consuming the most CPU. Now, it's not the most CPU of all sessions. If I look at all sessions, this guy here has consumed the most CPU. But that's a total number. And this thing's been running for 2 days. So it's not so much that I care about total CPU over the lifetime of the SPID. I want to know how much CPU is being consumed in my last data collection, in my case, last minute. So that's what the delta is saying. So this is that spike in CPU. This is that spike in the I/O. This is the growth in Tempdb data files that we just saw. The only thing I really don't know at this time is what command is coming in this stored procedure that's causing this problem, right? So I know it's a stored procedure, but I don't know exactly what the command is in that stored procedure. And one of the really good ways to see that is through query waits. So those query waits, we know it was session 70, I'm assuming this is that double spike that we just saw in Tempdb, broken down by weight types. If we look at it by session, 70, right? That's the teal color. So this stuff in here is 70. The first spike was 82. The second spike was 70. Statement associated to 70. Hey, guess what? It was the same statement, 2 sessions. The statement was insert into temp, right? It's a basically command I wrote that just grows Tempdb and doubles it over and over again until it runs out of space. But the general idea is pretty clear, right? Because we have a historical recording, essentially, of how the SQL servers behaved over time, and we have all these different resource facilities that we make available to you where you can drill in and look at SQL servers from basically every different direction. Is it resource? Is it query? Is it weight? Is it reporting, etc.? I now know in a lot of detail when the problem occurred, who caused the problem. So the statement, who the user was, right? The user was SQL admin. The application was this specific job, 2 different jobs, right? The statements were these, the database was this, the client machine that it was coming from was that, the session, etc., right? And I'm looking at a timeline here. Maybe instead of looking at a timeline, I want to look at a cumulative duration. By the way, a lot of those weights were 6 packet weights that we were seeing. But what I'm going to do is go in from an insert perspective, right? So this is the statement. Well, these were the weights that we saw on that statement. These were the databases affected. These were the clients. These were the sessions. And I'm looking at 1 hour. Let's change that to 24, right? Over the last 24 hours, which this will take a second to load up. But what I'm doing basically is looking over the last 24 hours at one single statement, and I can see that that statement came back in 4 different sessions, right? They were all related to one database, 2 different jobs, and these were the weight types that we saw cumulatively over the last 24 hours, right? Let me switch that back to 1 hour. So it's a pretty detailed view here that we're looking at. Now this is live data, and there's another approach that you could take to weight viewing, viewing weight data, and that is that I can step back pretty far from a timeline perspective. So if I jump back 8 hours, and if I step back pretty far, and then I look at the weight data, what this will generally do for you is highlight unusual activity, right? So if I'm looking at a 24-hour view of the server, as you can see down here, you know, this is kind of the normal workload that I'm expecting to see, and then we see this big crunch of something, and we see this one here, we see this one here. Well, let's drill into that and see what this was. All right, well, if I drill into that to see what this was some blocking, right? So using time, this tool gives you, like we just did with Tempdb, we found an alert, we drilled into that time frame, and we started looking at that SQL server from different perspectives. Another approach would be, let's go look at a view, like a weight view or a CPU view or something like that, extend that out to a wide swath of time, and then drill down into a narrower time frame like we did in this example. And by the way, there's a third way that you can do this, and that is more directly associating time to a problem. And what I mean by that is someone might pick up the phone and say, hey, listen, at 7 this morning, you know, in our case, it was like 7:20, right? So at 7:30, they called me up and said, hey, at 7:30, we had a problem. Well, if I'm looking at this view, at 7:30, I don't think they actually had a problem. It looks like that probably happened around 7:15, right? So you can manually drill into a point in time and then evaluate the server. So that's really how history kind of works, especially in conjunction with Tempdb. Tempdb is something that we have several different unique alerts around, and I guess they're not only unique alerting. Let me show you this a different way. So this was the problematic time frame, right? 7:21, right? If I go back and I look at this server from an alert perspective, when we were getting that alert, yeah, okay. So at 7:22 this morning is when we kind of peaked out at that Tempdb growth, right? So this was the alert that we used to get back in time. But as you can see, at this time frame, there were a lot of other things that we're alerting on, right? Tempdb free space, we only had about a gig left. Session 70 was using much Tempdb space. T drive, which is my Tempdb drive, the disk time was at 76%. The queue length was at 355, which is not good. And that was the OS queue length, and the average queue length had also popped up. And then the T drive was getting full, right? And then the reads or the writes, reads, and transfers were also indicating at that time frame. So if I'm having a Tempdb issue, I'm getting to see this in a lot of different ways, right? I'm seeing it from a resource perspective. I'm seeing it from a session perspective. I'm seeing it from a disk space perspective. There's a lot of things that this tool is picking up on to say, hey, listen, you're having an issue. And so much so that if I move forward, you'll start seeing a lot of these things are lowering, right? So they're no longer critical. They're getting better. If I keep going forward, everything is lowered. And then the server, now these are unrelated, but nevertheless, the server is kind of indicating that we're no longer in that problem. So you can walk through and see this stuff and really get a good understanding of when that problem has occurred. So when I talk about alerting here, there are quite a number of different alerts, again, as you just saw, that could indicate a Tempdb problem. If we look at the organization of these alert metrics, and what we're really trying to do here is define what is bad and what is good. So if I'm looking at Tempdb space usage, I'm saying anything over 200 megs is warning, anything over 300 megs is critical. We just saw something at 3 gigs, so obviously this is going to alert. But you can make your adjustments to put in what you think is most appropriate for your individual metric. That's the goal. And down here at the bottom, you'll see quite a few Tempdb specific metrics. So Tempdb space usage, that's the one we picked up on a minute ago. You also have Tempdb contention, which is looking at weight types within Tempdb, so gamma, S gamma, and PFS weights. You have your version store generation ratio alerting, so the amount in percentage by which Tempdb version store rate has exceeded the cleanup rate. And then you also have your size of version store. So those are some unique metrics that are really only related to Tempdb. But a lot of these other metrics are indirectly related. So for example, data full percentage, and I don't know why I set this the way I did, but I'm only alerting on Tempdb on this server. The other databases, which would fall under the category of default, the reason why, let me delete this. Let's redo this whole thing. So by default, you'll see something like this, right? Default threshold, and then I can edit that and put in what I feel, and they will already be predefined for you. But I can put in what I feel, from a full percentage, what is bad at a data file perspective. And maybe I have a different threshold for, every other database compared to Tempdb. So I could come in and say add, drop this down and say, well, Tempdb is different. I don't want it to live in the default category anymore. I want to have my own threshold. So we'll set a warning threshold at 50% full. So once it hits 2 gigs, and I'll show you in a second where I could type this. So we'll say 50. Once it hits 2 gigs, so then it's a 4 gig setup, and then maybe 75 for critical, right? So I can set unique thresholds for Tempdb and alert off of its full percentage. I could also do that based on size, which I don't do, but you could set a unique threshold for the size of Tempdb. If it gets more than this size, I want to be notified. You could alert off the file groups associated to that. You also, obviously down here a little bit lower, we were looking at things like reads and writes. So your average disk millisecond read, transfer, write. You also have your queue length alerting, which could have, notify you that the drives that are associated with Tempdb are super busy. Disk time and general resource stuff. You even can do something that I've done unique on this server, which is set up a unique metric that's counting the free space of Tempdb. So what this is doing is looking at something called a custom counter. And a custom counter really is designed to let you be whatever you want to be, right? So I can monitor anything I need to. Is it a WMI counter, like literally any kind of Windows counter, any WMI or perfmon counter? So let's say WMI counters, I can then pick a sample server, and then there's a whole host of WMI metrics that are now available for me to pull from, and some of them are obviously SQL related, but they don't have to be, right? You can look at the print queue. Someone plugged a printer into your SQL Server. Well, let's see what they're printing, right? So you have tons of different things that you can work from. You have SQL Server counters, right? You have custom scripts, virtual machine counters, so VMware and Hyper-V. There's about 285 VMware counters we could pull in here outside of the normal out-of-the-box ones, and then there's Azure counters as well. But what I did was I ran a SQL statement just to calculate the free space of Tempdb, and then I built an alert around that. So let me show you what I mean. So the collected value is what I'm after, so that whatever's returned in that SQL statement will be the free space available. And then I set a lower value is worse than a higher value. Information threshold. So information means it's empty. So 400 roughly, 3,000 megs, and then 2,500 megs would be my alert threshold. So lower value is worse than a higher value. Once that custom counter is created, if I go look at that SQL Prod 1 dashboard, I've added that as a chart, so you'll see that dropping, right? So the alert that we saw, that first spike in Tempdb, you'll see it here. It corresponds with the drop in Tempdb space there. Let's go forward. You see that first spike inverse, right? So these are inverse because this is looking at the size, this is looking at the free space. Anyway, the idea is that there's lots of different ways you can kind of get in here and get into this stuff. One thing that we didn't talk about, though, was tuning. Now, tuning queries can also be done, and there's different ways that you may do this. Hold on one second. Okay. Just want to make sure I had something else running in the background. So when I'm looking at those queries, and remember, this is that section of the tool I talked about where I'm using Query Store, and I said anything over 1 second. So here's my 1 second threshold. I'm using Query Store. So when I'm looking at these average durations here on these queries, notice none of them are below 1 second because I didn't ask for those. I asked for the ones that were over 1 second. And the view that we're on right now is signature mode. And the good thing about, the good thing about signature mode is that it's counting for me the frequency of a specific statement, batch, store procedure, trigger, et cetera, had been collected. So when I look at the occurrence column, 42 is my big number, average duration. So it just so happens this one is running most frequently and running the longest, right? So this is definitely something that I'm going to want to tune. I can pull the text up, but this isn't the real query. This is the query signature. Also, if I click on the details button over here, which is the execution plan, this is not, this is the most recent, I guess, execution plan, right? There's 42 occurrences of this statement. It's showing me the most recent execution plan. So once I've kind of identified, hey, this is the query I want to tune, I'll say show query history, and then that will show me all of them. And that's kind of interesting. I can talk about why that is. Oh, part of that is, hold on, I was looking at a narrower slice of time. But when I'm looking at the duration now, we can see that this query, so let's look at it from a chart perspective. This statement, which this is the real deal, right? This is the statement. I'm actually going to Control-C, copy that to my clipboard. If I click on this gray dot here, this is the execution plan for that specific run. And then this is some charting of this statement over time. So this is the same statement over time, and it normally is kind of down here, and then all of a sudden, boom, it grows. It takes a lot longer to run. Then it runs normal again, then it takes a lot longer to run, right? What this actually is those blocks we saw earlier. So when it gets blocked, it takes a long time to run. And another way to kind of visualize that is these are the ones that took forever, but notice their CPU time and their reads are the same as everything else. So something else, some external force was pushing on this statement. It was a block. So what I can do with this now that I have the actual SQL that was being run is I can go tune it. There's two different ways you can do it. There is a kind of basic higher level type tuning system built into Diagnosmeter, so I can say diagnose query. It's going to go look at things like query syntax and indexes and try to figure out if there's a better way to do this. In this case, there's nothing really wrong with the query other than the fact that it's being blocked every once in a while. So maybe if I went after the lead blocker, it would give me some recommendations. This is the block statement. Though one of the things that I do kind of look at, though, in this standpoint is that it is using a lot of CPU. And this thing runs every 5 minutes to populate a dashboard. And frankly, I don't care if it takes 30 seconds to run, because it just needs to update every 5 minutes. So maybe what I'm concerned about is the fact that it is using so much CPU. Show query history, sorry. It's using so much CPU. I don't like that. So when I go to tune this query, what I might do is tune it for a different parameter than time. So what I'm showing you here, this is kind of off script, but I'm going to show you anyway. This is a tool called SQL Query Tuner. We sell Diagnosmeter, and then we sell Diagnosmeter Pro. Everything that we've looked at so far, literally all this stuff in here, this is standard Diagnosmeter, this is the normal stuff. If though you want to go with the Pro version, really what the Pro version is going to bring to the table is a secondary product called SQL Query Tuner, where I can come in and say, hey, let's new tuning job. Let's tune a SQL statement, that select statement, and I'm going to have to connect into the SQL Server, and I'm going to have to find the catalog of, I think that's IDERA Forum. Where are you? So this is the database, right? So the statement, the database, how it's going to run. And what I'm doing here is I'm going to say, let's go ahead and have this tool run through a bunch of algorithms, try to figure out every possible way I can run this query to get the same result. Not only do that, but once you found those different examples of how to run the query, run it once, and then come back and give me a breakdown of how they performed. So, and I've already done this, but you can see it's kind of going through all these different examples down below and seeing how it can work. And we're not going to wait on this because I have already done this. So this is what it came back with, right? So it came back with all these different, it didn't, you know, I can't run this infinitely different ways. These are the different ways I can run this SQL statement. These are the total cost, the elapsed time, the physical reads, logical reads, CPU, right? So if what I'm trying to, you know, kind of solve for is lower CPU output on this statement, the maxed up one off. So if I say compare to parent, right, this would actually maybe fix some packet issues I'm also running into. But this is the original that we brought in. If I change the statement with the maxed up one, right, at the bottom, I get lower CPU. If I want to run this the fastest way possible, up block one, so this change here would make it run a little bit faster, right? So I guess I just want to point that out, right? Maybe we've identified what your problem statement is in SQL Diagnosmeter. That's easy. Tuning it, there's a couple different ways that we can help you tune it, I guess was my point there. So this is an add-on to Diagnosmeter called DM Pro. And let me show you this a different way. So if you look at Diagnosmeter for SQL Server on our website, you'll see Query Tuner in the background. That's what that little thing is in the background. Also, let me see if I have an example for you. There's a separate tool called Workload, and I've been running a beta. I wasn't planning on showing you this today, so I apologize. This is a beta of something that has not been released yet, but there are existing versions of Workload. This build here is not production yet. But what this is really doing is a dynamic management viewer. Basically, it's collecting DMVs every second, then populating them into different sortable views, right? So I want to look at DMVs by user, by machine, by application, by statement, how frequently they're running. So if I go to that select statement, which was this one that was being blocked, right, I can look at its performance over time. It was an internal wait, right? How much time, and then I can drill in and get execution plans and things like that as well, right? View the execution plan. But this is monitoring very differently than SQL Diagnostimator. Diagnostimator, in my case, was monitoring once a minute, but looking at every aspect of the SQL Server, getting in and looking at things like jobs and logs and, index fragmentation, things like that. Query Tuner is only looking, or excuse me, workload analysis is only looking at kind of workload through a DMV perspective. So we have about 10 minutes left. I'm going to take some questions here, and then we'll look at some reporting, I think, as well, and maybe some alert responses. So I'm adding instances, John. So if I have a bunch of named instances on one server, I'd still have to add them individually. Also, if you're thinking about things like a traditional Microsoft SQL Server failover cluster where I have one instance, virtual instance across two nodes, I'm not adding the nodes, I'm adding the instance. With always on, it's a little tricky in that you have to make a choice. For example, here I have AG1, AG2, and AGL. AG1 is node 1, AG2 is node 2, AGL is the listener for an always on availability group. I can monitor just the listener. I can monitor the individual nodes. I'm actually doing all three. Most people would never really do that because that's 3 licenses. This tool is licensed by instance. But let's say that your AG is set up for a secondary reporting server and a primary transaction server. You might want to monitor both. If maybe your secondary is just for DR, you maybe just monitor the listener because the secondary is not really going to do anything, right? So you have some options there. So instance-based monitoring. Estimated query plans are how things are configured out of the box. Actual query plans are very expensive to collect. We generally don't collect actual plans. You could force it to do that, but we wouldn't necessarily recommend it. What I would probably say to do, Scott, is, Query Store is great. One of the problems though with Query Store is you're looking at database by database, not instance wide. Our tool will combine all that database data together. So it may be that from time to time you jump out to the old school traditional Query Store in Management Studio, but estimated. Is there a way to save deadlock, lead blocker, blocking process IDs in the SQL? We have deadlocks issues. So all that data is stored historically for 30 days, right? So all the deadlocking information, all the blocking information, you'll have blocking and deadlocking reports. We keep that historically for 31 days out of the box. So yes, we do keep that stuff. The process ID, yeah, it's in there. So I/O latency for data files and throughput, I mean, there's different ways to measure that. So you can look at literally the disk performance, but you can also look at weights associated to the database that may give you some indication around the data files themselves, but there is data there. KB knowledge base associated to alerts, so notes, yes. All right, Scott and John have a lot of good questions. So John's asking if there's a way that I can maybe annotate. Let me show you what I think you're talking about, and you can correct me if I'm wrong. So Tempdb space usage. All right, so we saw this alert earlier. Well, I can go into this comment section and say, last time this happened, XYZ, blah, blah, blah. So I can input my own internal knowledge base information into these alert metrics, right? So you can put a whole workflow in here of how to solve the problem related to this alert into the actual metric. And this is going to be instance specific, right? And then once I've done that, when you set up your alert action response, which we haven't really discussed yet, so you may have noticed that my Tempdb never hits 100%. Part of the reason why that is I built a little back-end script that kills the SPID that's chewing up all the space and then shrinks Tempdb. So the way this is designed to work, and let me add into that question about knowledge base article email. So we'll go to David at IDERA.com. All right, so that knowledge base piece, that comment section, I'm going to add that to the bottom of my email, right? So when it happened, metric, severity, alert text, this is basically, what the email will look like using variables from the alert text. And I'm going to put my own little knowledge base article piece, that comment section at the bottom of the email, right? Last time this happened, XYZ. The other thing that's happening here is I'm using some variables. I guess that the shrink isn't in there, but that's okay. I'm using the alert summary variable that has the SPID in it as a string and parsing that to get the SPID that's causing the growth and having it killed automatically. And I don't know why I took the shrink out, but maybe I put a shrink in there as well. But essentially what you're doing, and maybe as a better example, I guess I took the email out. How those variables work is, so you have all these different variables that you can plug in, so that you can plug it into a Powershell script, you can plug it into a SQL script, you can plug it into the subject, you can plug it into the body of the email, right? So you're using information that comes in. The query tuner stuff, what I would recommend, if you have questions about query tuner, just for the sake of time, it might be best to go to your account manager and we can set up a separate call around that. But generally speaking, you can't, you can use parameterized queries in SQL Query Tuner, but you're going to have to actually put in values for that. So SQL Query Tuner, you have to type in, it only works with queries that are runnable, right? So the statement that you're putting into Tune needs to have all the variables already pre-input into it. So you might have to take a little work there. So can alerts be extended with a custom .NET DLL to accomplish HTTP WebSocket to MS Teams Slack? Well, there's a lot of different ways that these alerts can be distributed. So email being one of them, and I'm not saying that email is the best way, but for example, ServiceNow, email is the best way. So I can send an email to the ServiceNow provider. The ServiceNow provider can then read that email, you look at the subject or the body or something to parse that its diagnostic manager and then create an incident with that, right? As another example, you could use something like Windows Event Log. So an event log scraping tool like SCOM, SCOM, maybe I was really referring more to like, I'm blanking on it now, Splunk, right? So Splunk might be scraping the event log, so that's another way you can integrate in. If you wanted to do something through like a DLL, it might be that you're running a program, which is kind of command line script. So you can, these alert variables pass the switches to a EXE, and that EXE does some work, right? So an example might be HP OpenView. You can also send out SNMP traps, right? So I have some monitoring system that's sitting out there that can take a trap. I can send all my data in that direction. And then lastly, probably for teams would be PowerShell. So I can run PowerShell scripts, and there's PowerShell commandlets obviously for teams where I can pass the variables from the alert text into the PowerShell script, and then that integrates in with teams. So there's a number of different ways that potentially you could get there. Which one's best for which environment? I think PowerShell is probably best for teams. I think email is best for ServiceNow. Splunk, obviously, event log. Remedy could be an EXE, so command line and ServiceNow, and SNMP and email for that matter. So there's different options that you have, but pretty much one of those generally works for most people. So the only thing I didn't really talk about was reporting, and we have about 2 minutes, so I'm not going to get into this in a ton of detail, but let me just mention quickly, since the subject of this was Tempdb. So under Analyze, you have Tempdb statistics, its own report, and frankly, the idea in here is that we chart, at the top you'll have charts. At the top, you'll have a chart, and we'll see what this looks like. And then at the bottom, you'll have a table with a bunch of different metrics. I probably shouldn't have done minutes. Probably should have done hours or something like that, but that's okay. So this is Tempdb transactions per minute or per second, excuse me, and then down below you have all these different values that you can look at, right? You also can report on things like disk statistics, so how busy is my T drive. You can look at disk space usage or disk space history. You can also do something like a forecast. Now, Tempdb may be a stretch, but I will show you a forecast because this ties into the SSRS discussion. Forecasting reports, which there are 3, disk, database, and table forecasting are not available in SSRS. Everything else, though, all the other reports in the tool can be deployed to SSRS. So what that means is that, I can use SSRS subscriptions and customization, rebranding, all that stuff on every other report, except for these 3. And the reason why these 3 reports you cannot do that is because it's using the past to predict the future. So we'll do a linear forecast algorithm to look at my DM repository database. My DM repository database is a little unusual because I mainly deleted a ton of data out of it because I ran out of disk space. You'll see this in the chart. So we're going to look at the last year's worth of growth, and we'll use that to predict 90 days into the future, and we'll run this report. So you'll see, and let me show the free space too, sorry. So the dotted line is the disk available. So earlier on in the year, my disk was a 25 gig, or it was 25 gigs, I think, and roughly I ran out of space. So I'm on a laptop. I don't have a lot of space to deal with. So I deleted a bunch of stuff manually out of the repository, and now it's growing again. But the idea is that the blue line is the reason why we can't take this out to SSRS, because the blue line is a linear forecast algorithm that SSRS does not understand. So mainly I'll have to build these reports. But the report section is pretty straightforward, right? You have monitor reports, which are more real-time, analyze, which is more historical, planning, which is looking at the future. Obviously, these tools are available for downloaded trial. So my goal here is, if you're not already a user, is to kind of hopefully tempt you a little bit to download a trial and start working with it. I think once you start working with it, you'll find it indispensable. Most people love this tool. We have lots of people move to new organizations, say, hey, I used it in my last company, I need it now, I need it back. So if you want to do a trial, under the products drop down, you'll see SQL Diagnostic Manager for SQL Server. Hit start for free, we'll give you a download. It's 15 servers, 2 weeks is the default. That'll get you into our system. And if you need a one-on-one demo or help or anything like that, you'll have someone to contact around that. Let me check the questions one more time. I don't know what I did with them. Here we go. I think I covered pretty much everything, and we're over by 2 minutes. So I do appreciate everybody's time. This was recorded, so we will distribute that out to the people who signed up for it, I think later on today, maybe tomorrow. And with that, you guys have a good rest of your week. Hopefully this was of value to you. Take care.